Since we know that depth first search can be non-optimal as well as it may not be complete, there are certain alternatives to depth first search which try to address these issues in the depth first search, and those alternatives gives you two more algorithms which are again blind algorithms. They are also uninformed algorithms. One is referred to as limited depth first search, okay, and the other one is called as iterative deepening depth first search. Now we know that the depth first search can get into an infinite loop in one direction. So if I want to stop it going further than a particular depth limit, okay, then I can actually make such arrangement in my algorithm. How do I arrive at this depth limit? Because to arrive at this depth limit, we can actually have some experience of solving same problem. So we know that if there is no solution, say 3 level deep plus, okay, so 3 level deep तक solution नहीं है एक direction में, then there is no solution to this problem. If we have such insights like this about the problem we are solving, these are not something to do with the problem domain information. We are just maybe deciding this heuristically, deciding this based on our judgment that, say, suppose we are playing tic-tac-toe game. We know that there are 9 cells and we need to put crosses and circles. So we may say that there would be only 3 ply at max before we get our result. If the board is 3 cross 3 and we are playing tic-tac-toe. So I may say that, okay, there is no point in searching for the solution beyond the 3rd ply or 3rd action. I need to only search up to 3 actions. Okay, so that is how we need to reach at some depth limit. And once you go in a particular direction, as a depth first search algorithm goes, up to that depth limit, you're allowed to go. Once you reach that depth limit, it is like a stopping condition to stop exploring that particular direction, and then you start exploring the other side of the subtree. Okay, so that is called as depth limited depth first search. This depth limited depth first search implementation can be a recursive implementation or a non-recursive implementation. I have shared these notes with you, so I want you to go read this in particular algorithms and make sure that you understand them, how they are implemented. We'll be solving some problems in practicals where we might actually see their implementation as far as the codes are concerned, but we'll use ready-made implementation. We'll just set different levels of L and understand how the algorithm behaves. That is what we are going to do in the practical sessions. Now, the other alternative to depth first search is iterative deepening search. So depth limited depth first search का भी एक problem है. अगर मेरा search tree में level L से आगे कोई solution है या मेरा solution level L के आगे ही है, तो depth limited depth first search will not get the solution. क्योंकि हम लोग उसको लेवल L तक ही रोक रहे हैं, तो पूरा सर्च होने के बाद L लेवल तक का ट्री, even I won't get the solution, and hence I will never get a solution even when the solution exists. That's the problem with depth limited depth first search. So it is not again a complete algorithm. It addresses the problem of going into an infinite loop and not being complete because getting stuck. लेकिन अगर solution depth limit L से पहले है तो ही फिर ये algorithm काम करेगा, otherwise this algorithm will not work. Now iterative deepening depth first search on the other hand does what? It actually manipulates the depth limit starting at L0, then it makes level 1, then it makes level 2, then it makes level 3 and keeps on doing depth first search. So it is actually like, rather than solving the entire problem, first solve small portion of the problem, try solving it, doesn't get solution, increase the breadth of the problem, increase breadth of the problem, or depth of the problem, increase depth of the problem. This is how it tries to solve. So iteratively, it deepens the search. So initially you only search one single node, then you search the root node plus first action, then you search root node plus 2 action deep tree, then you search root node plus 3 action deep search tree. And if you get the solution, you will always be getting an optimal solution in this regards, right? Because it is actually trying to mimic a breadth first search. breadth first search ऐसे ही काम करता है, पहले रूट नोड, फिर लेवल 1 के दोनों नोड, फिर लेवल 2 के 4 नोड, ऐसे ही सर्च करता है, right? So that is what iterative deepening search could work like. So depth limit, it initially will be 0, so you'll only explore A and you'll figure out that there is no solution here. Then when depth limit is 1, you will explore A, then you will explore B, then you will explore C, and come to know that there is no solution here. Now depth limit is 2, then you will start exploring A, that is level 0, then B, then D, then E. So the exploration is different at depth limit 2, and you are repeating some work again. पहले आपने depth limit 1 था तो A को explore किया है, लेकिन फिर भी जब depth limit बढ़ जाता है तो A को फिर से और B C कर रहे हो आप, फिर से explore कर रहे हो. But if you in general see this in a high level fashion, you will understand that what you are doing is you are kind of doing a similar kind of trace like a breadth first search. So you are keeping the benefit of depth first search of utilizing least amount of memory compared to breadth first search, and you are also attributing the property of being a complete solution like breadth first search. That is what is benefit of doing or having alternative of iterative deepening depth first search. So that's how the things would work. Okay, you ultimately will reach goal node G at depth level 3. Okay, so iterative deepening depth first search का यहाँ पे analysis करके दिया है. It says that the overhead for this algorithm is around 11%. तो 11% overhead है, लेकिन इसमें benefit भी होता है. Okay, और उसका कुछ एनालिसिस करके दिया है. अगेन दिस इज नेवर आस्क्ड इन द एग्जामिनेशन, बट यू कैन इमेजिन दैट इटरेटिव डीपनिंग डेप्थ फर्स्ट सर्च में बुक कीपिंग बढ़ जाता है आपका. यू रिपीट सर्टेन अमाउंट ऑफ स्टेप्स एंड दैट इज ओनली 11% on a large case problem. Okay, but the positives of iterative deepening depth first search is that the algorithm is complete as well as it is going to be optimal solution. It is going to give you an optimal solution because it is tracing the state space like breadth first search traces it, and it is utilizing the memory as the depth first search is utilizing it. So that's the benefit out of doing iterative deepening depth first search. The only overhead we need to commit is थोड़ा टाइम कॉम्प्लेक्सिटी बढ़ जाता है, बट हमने देखा था दोनों का टाइम कॉम्प्लेक्सिटी, द डेप्थ फर्स्ट सर्च एज वेल एज ब्रेडथ फर्स्ट सर्च, दोनों का एक्सपोनेंशियल था. ऑब्वियसली वन वुड बी लेस, दैट इज ब्रेडथ फर्स्ट सर्च का कॉम्प्लेक्सिटी थोड़ा लेस होगा देन डेप्थ फर्स्ट सर्च, बट स्टिल वी कैन से दैट at least we have an algorithm. If we have a space constrained device, we have an algorithm that works well with respect to the given space, and it is complete as well as optimal, in a sense that it gives you optimal solution, and if the solution exists, it gives you definitely the solution. Okay, so it does not have the drawbacks that in general depth first search has. So we talked about today 5 algorithms: breadth first search, uniform cost search, depth first search, depth limited depth first search, iterative deepening depth first search. Depth limited depth first search tried to address the problem of not being complete, that the not being complete and optimal by limiting the depth limit that you use for searching. But it has a problem if the solution is not before the depth level L, the first solution or the first optimal solution as they call, then you will never get the solution and you are not still complete as an algorithm, and you are not going to give an optimal solution. So alternative, one more done, is called as iterative deepening depth first search, which is like depth limited depth first search, but we iteratively increase the depth limit. This iterative increase in depth limit asks you to add certain overheads which are around 11% in terms of the bookkeeping that you need to do extra, or extra exploration that you need to do, or repeated exploration that you need to do, but that can also be avoided and reduced. Okay, This makes the iterative deepening depth first search algorithm complete as well as optimal. So it is complete, it is optimal when the step cost is 1, the time complexity is O of b raised to d, and the space complexity is linear like depth first search. Okay, so that is the best algorithm that you can think of, which tries to balance both the things. Okay, it works like breadth first search, but it has properties of, or it has the working of depth first search like behavior. And this is the summary of the entire lecture. Okay, so the things that you need to remember when such question comes into your exam is, what do you mean by completeness, what do you mean by time complexity, space complexity, what do you mean by optimality. You need to understand what these algorithms are. Okay, these are the extensions of the depth first search algorithm, both of them. This and this, they are very much closer, the only difference being one has the queue fringe as a queue, the other one has fringe as a cost. So uniform cost search is alternative to breadth first search that considers the cost of actions or cost of traversing the tree path as well. Okay, so looking at this big picture, you understand that there are definite issues in depth first search with when it comes to the completeness and optimality, but definitely a positive as well in this algorithm, and the positive is the space complexity. So this positive is taken up by the iterative deepening search, and these two negatives are corrected by it as well. Okay, and this b raised to d, b raised to d plus 1, so this both things are comparable again. So iterative deepening wins over even the breadth first as well as depth first search algorithms in that sense. Okay, ये टेबल बनाना, ये टेबल में जो भी कॉन्स्टेंट्स यूज किए हैं उनको याद रखना और उनको रिप्रोड्यूस करना, दिस यू नीड टू अंडरस्टैंड एज फार एज योर 7th semester examination is concerned, because they ask questions like compare various compare various blind search algorithms, or compare various uninformed search algorithm based on certain universal criterias, or they might give you criteria and they might want you to compare these algorithms one against the other. So if such question comes for 5 marks or even 7 marks, you should compare all these 5 algorithms with respect to 4 criterias. You should draw this table, you should explain the constants, and then you should also comment on what algorithm is going to benefit because of what reasons. Okay, the entire lecture that we talked about today. Okay, so that is about the uninformed search algorithms. Next lecture onward, we will talk about informed search algorithm. Now, one important thing that happens is repeated state. So if I have such kind of so this is the state space on the left hand side, and this is the tree that is generated because of this kind of state space. So I have node A, next successor is B on the left hand side and B on the right hand side. Now B has again two successors, C, C, and this B as well has successor C, C. So you'll see that this kind of an environment will have a repeated set always. Okay, even with the directed graph. So this state space is directed. इससे पहले का स्टेट स्पेस हमने देखा था वो डायरेक्टेड नहीं था, तभी भी जो ऑफ दैट पर्टिकुलर रोमानियन ट्रैवर्सल, तो ये जो स्टेट स्पेस ऐसे है जो डायरेक्टेड है लेकिन वो लूप फॉर्म करते हैं. ओके, उनमें रिपीटेड स्टेट्स होंगे, और रिपीटेड स्टेट्स को अवॉइड कैसे किया जाता है? रिपीटेड स्टेट्स को अवॉइड करने के लिए ट्री सर्च एल्गोरिथम को ग्राफ सर्च एल्गोरिथम में कन्वर्ट करना पड़ता है. You need to maintain two data structures now. One is to maintain the unexpanded node, that is fringe list, and the other data structure that you create is called as the close list. There are many names to it. Some people call them, or some books call them, close list. Some people call them explode node list. Okay, and there could be various other names as well. Okay, so we can call it as closed list. So closed list will be list of those nodes which are already explored, and we have already found that they do not have the goal test followed. यानी ऐसे नोड जो फ्रिंज में पहले आ चुके हैं लेकिन उनका गोल टेस्ट फेल हुआ है, उन नोड को आप एक्सप्लोर्ड नोड के लिस्ट में या क्लोज लिस्ट में डाल सकते हो. दिस विल सेव यू लॉट ऑफ अननेसेसरी expansion of your queue, and this could benefit to reduce the amount of space required for breadth first search as well if I maintain a closed list. Okay, so this is the algorithm that I again want you to read on yourself and get acquainted with.